So hello everyone, can someone hear me? And I cannot see myself yet. Okay, people can hear me, but they cannot see me. Strange. Okay, no worries. Maybe there's a delay. But anyway, I would like to introduce you Nicola. So he's a Microsoft MVP. So he's going to talk about C# 12. So what's new and interesting. So thanks for waiting for a big after a big break. So Nicola, so you can introduce yourself also.
Yeah, hello
Good luck.
everyone. Thank you. Hello everyone, my name is Nicola Iarocci. As mentioned, I'm a Microsoft MVP from Italy, and I'm here to talk about C# 12, what's new and interesting, which probably means that it's not really new anymore because C# 12 has been around for a while now. Maybe some of the features of the language, the new features, you've been using them already. But I thought it would be a good idea to go a little deeper into the main features, which in my opinion, you see them listed here. The main features are without a doubt the primary constructors and collection expressions. Then there are other features that we will give a look at. I'm not going to talk about interceptors, which is the last feature here in the list, and that's because they are in preview, which means that the API for interceptors might change in the near future. So it's probably something you don't want to use right now in production. And also the experimental attribute, the second to last in this list, is just an attribute that you can use to flag a class or a structure as experimental. And they made it rightly because they needed it for interceptors. So basically they released a new stable version of C# and they added interceptors as preview thanks to the experimental attribute. This is basically all there is to say to these last two features. But let's go and give a look at primary constructors that I believe should see a wide adoption rate in the near future. Let me go to the code. I have here some examples, some demo code. We have a structure here and it's called distance, and there is something weird on this line because we don't have a constructor method, but we have what I call primary arguments, the input arguments for this constructor right here where the declaration of the type is. So we are accepting the two doubles and we don't have the constructor itself. This is an old style class or structure, like in this case. This is how we always coded constructors until today. We have our declaration, visibility, type, and then we have a method that is a special method, a constructor indeed, where we declare the input arguments. With primary constructor, we can get rid of this method and we just declare the input arguments right there where we declare the type. Now, because we don't have a method, we can use the input arguments anywhere in the type. And you see me using them here, in many places in this small structure. If typically you end up building a hidden field, a class level or a structure type level field, but you don't need to do that with primary constructors because they are already in scope within your type. That's nice. Again, code that you don't have to write anymore. And another interesting thing here is that these arguments are not static, officially static, I should say, but you can consider them as if they were static. You see that because here we can use this argument in this property assignment where this is a read-only property, like the structure itself, it is also read-only, but we can use the initialization argument here and use the input arguments right away. In this case, this is easy because the structure is read-only, but here I have an example of a mutable distance class, because until now we've seen the types, the primary arguments being used in a read-only mode. And in fact, the compiler in this case will not create any backup field for these arguments because they are in scope. And they don't need to be captured because they will they will be used on class instantiation, right? Here instead we have the same distance structure, but this one also has a translate method which is accepting two delta fields and is changing the values of our input arguments, the primary arguments as I call them, because they are of the primary constructor. So yes, the primary arguments can be changed, you can use them, you can modify them, but again, these are not class members. We can't do this dot. We get an error because these are statics, in fact. Even if some kind of black magic is going on here, because this is not a static method, and yet we can use these as if they were statics. In fact, the compiler is going to use a backup, a hidden field. We don't have access to that field. We use the arguments right away, but in fact, it is going to use it. But the compiler is going to optimize and only build the backup field if it is needed, like in this case. In this case, it is needed because the values are captured and subject to modification if the translate method is used. Another difference with the previous class is that here we are using body methods for the properties because, in fact, we have to use the current value of dx and dy in case they have changed because somebody invoked the translate method. So they are in scope, they are mutable, you can use them by all means as if they were backup fields that you updated in your old style constructor method. These are two key points to keep in mind, along with the concept that in any case, these are not members of the class and that this keyword, it won't work. Now, primary constructors are not really something new, because if you think about it, already in, I believe, C#9, we had records. Here I have a student record, and records are actually using primary constructor and always have been using primary constructor. If you look at this syntax, it's very similar to the syntax we have in my distance structure here. There is one difference, notable but subtle difference, and that one is that the arguments name are capitalized, whereas in my class they are not. And why is that? Well, with records, when you define a primary argument in the primary constructor, these are going to become properties, and so they will be accessible from the outside. If you declare an instance of student, you can ask for student.name and you will get a value. But in your custom types, be them classes or structure, you won't get these properties for free. If we go here to the program where I'm instantiating a distance, and then I try to print, distance, the x, it won't work. I don't have access to it. If I want to expose those values, I actually have to implement the properties, right? And that makes sense because custom types, you not always, I will say most of the time, you don't want to expose the input field, the primary constructor. If you have to, you can do that, but you have the option. Whereas records are typically used in data transfer as data transfer objects or DTOs, and so you usually want them to be, the properties to be available. So in records, we have kind of a shortcut. We don't have a choice. They are always public. Whereas here we have the option to decide if they are public or not. All right, we saw the main points of primary constructor, but there are still many questions to answer. The first one is, what if I want to create more than one constructor? I have a primary constructor. Can I add a secondary or tertiary construction? Constructor? Yes, you can. In this version of the mutable structure, I added a parameters-less constructor. You see it here. So this mutable distance structure can also be initialized without any parameter. The trick here, what you have to do is to always remember to call the primary constructor. And you do this in this way. I'm calling the primary and passing 0 and 0 as values for my two arguments. So to answer the question, yes, you can have as many constructors you want, even if you have a primary constructor defined for your type. Another question, a very valid one, is if I don't have a method, how can I validate the input, the arguments? How can I validate them? Well, you can do that. There is a pattern for doing that. Here I have a bank account class. It is using a primary constructor. Two arguments are coming in, account ID and owner. And look at this property. When I assign the property, I can validate the input arguments right away. I'm calling a static method called valid account number, and this static is checking that the account ID is 10 characters in length and they are all digit. If there is a match, if the value is valid, I assign the property, otherwise I raise an exception. Because they are considered, these one are considered static, and the function is also static, I can use an initialization operator, which means that when I instantiate this class, I will get an invalid account number error as soon as I instantiate it, precisely the same behavior that we have with old style constructor. Let's see this in action. Right, so here I'm initializing a valid bank account, but if I go here and change this to an invalid, a not digit character, and try to launch this application, I should get an exception there, invalid account number, which is exactly the behavior we will get with an old style validation made within the constructor method. So to answer the question, yes, you can validate your input values. Of course, in some situation, you might need to do more than this. Maybe you have some complex domain logic. You want to do something more complex, but well, you can always fall back to the standard constructor method. Nothing prevents you to do that. Primary constructors are still an option. They are not mandatory, of course. But most of the time, you can get away with a pattern like this to validate your input arguments. And then another question is, what about inheritance? Here I have a bank account class, super simple, just two properties, and a primary constructor again. Well, if I have a secondary checking account class, this one is also using a primary constructor. It is adding an optional parameters, because yes, you can have optional parameters in primary constructors too. The way you inherit from a primary constructor class is by simply adding passing the arguments to the class right here in the declaration line. So I'm inheriting from bank account, and this is the value for account ID. It comes into my subclass, and then I pass it to my base class, the same with owner. So you can very easily inherit from a primary constructor class. But many times, especially in this transition moment, you might have a legacy class that it is not using a primary constructor. And what if you want to inherit from a class that has a primary constructor? That's also super easy. You simply do the old way, you go the old way, so you inherit from bank account, and then in your old style constructor method, you pass the two primary arguments to the base constructor. Basically, this is the old syntax we have always been using, and it is still valid, which means that you can freely use libraries that are already have already transitioned to the new syntax without any issue. You won't even notice that something has changed and that the library is using primary constructor. This is very important. Now, there is one strange behavior I saw and I wanted to share with you. This is again a saving account class using a primary constructor, and it is inheriting from our bank account using the syntax we just saw. All looks good, but if I remove this pragma warning disable line here, I get two warnings, two squiggles. You can see them here, I hope. So why is this? These two warnings are there because in my code, I am capturing these two values and I'm using them right here. Let me close this one so you can appreciate the whole code. Right, so account ID is used as a primary argument and owner as well. They both are used here in the override to string method. So because this class, the subclass is capturing these values and it is using them itself, and it is also passing these values to the base class. And the base class is also capturing these values and using them. We've seen that here. It captures the values and then it prints them and it uses them to assign the properties. Then the warning is telling us, look, you are capturing these values in your subclass. If you change these values either here or in the base class, you run the risk that the two copies of the values might change in one instance and not in the other. So they might go out of sync. Now, the obvious solution in this case is super simple. I should just use the properties. The properties are in the base class, the warning goes away, no problem anymore. But there might be some use cases, I don't know, I don't have an idea when, in which you want to have this behavior, you want to use the primary argument right away in your subclass. In this case, you get the warnings, but you can disable them by activating this pragma option. You probably don't want to have this pragma on. You want to refactor your code in order to not to have this issue. But if you need to, you know how you can do that. All right. I also wanted to show you, oh, this is too small. Probably you can't read anything here. Let me see if I can increase the font size. All right. This is production code. This is a web API controller. And I wanted to show two things here, light code, not a demo, but also how Visual Studio and Visual Studio Code both offer support for primary constructors right away. Here, if I go in the constructor method or style constructor method, I'm offered the option to switch to a primary constructor. If I do that, I get a refactor for free here. I still have the backup field. This is because this variable is being used, as you can see here, within the code, but I can fix this by deleting the line and switching to my, what's the name? Data service. And there is another occurrence here. Right, so now I fixed my code. Less boilerplate, as you can see. I find it is super understandable what's going on. I'm receiving via the dependency injection, I'm receiving this data service, and then I'm using it in my controller code. Here is another example. This monster is receiving a number of services. If I remove this line, because otherwise it won't work, I can fix this and use a primary constructor, and everything is moved up here in the declaration. And again, I should probably delete all these lines and less code, and the code is more easy to reason about. All right, let's switch back to the slides and see a quick recap so we make sure that I didn't forget anything. So you can now add parameters to a struct or a class declaration. Parameters are in scope throughout the class definition, as we saw. They are not stored if they are not needed, which is very nice. When needed, the compiler creates hidden fields to represent each parameters, and they aren't members of the class. So you can't use the this keyword. This is important. And they don't become properties either, except for record types, as we saw, but we can create properties if we need to. Secondary or parameterless constructors are always possible. You can do that. You just need to invoke the primary constructor. And validation can be added when assigning the corresponding properties. No problem with that. We see the pattern. We saw the pattern. A derived type can have a primary constructor, and it must invoke the primary. And at the same way, a derived type can also not use a primary constructor, and everything will work just fine. In derived types, watch out for nested captures. We saw what can happen when we have nested captures and how we can fix it, or get around it by enabling the pragma keyword. We saw that Visual Studio and Visual Studio Code and also JetBrains Raider, they all support the primary constructor and offer refactories for it. And one thing I wanted to share with you is that they are not new at all. Back in 2015, they were implemented in C#6. For a short period of time, they were available in a preview of C#6. Then they were taken back to the drawing board, and we didn't see them until C#9 and the records, and then in C#12 we have them again, but the implementation and the logic about them is basically the same that was available in the C#6 preview back in 2015. So nothing really new here. All right, let's go and switch to collection expressions that are a very nice feature. I love collection expression, and I hope most of you will start using them in their code because they offer significant advantages. Let me delete this code and insert a node style bunch of examples. This is how we initialize collection until today. Look at the first two lines. We are, in both cases, we are initializing an array of integers. The first case, we are passing some values. In the second case, it is an empty array. But look at how different the syntax is for the same, essentially, the same task. Doesn't make a lot of sense, does it? And then look at this one. We are calling a method. If we go and look at this method, it is accepting an array of bytes. But we forced to do a lot of casting because when we type 1, 2, 10, whatever value, these are integers by default. So we have to cast to byte. And then here we are initializing a generic list. Here we are creating a span of datetime values, and we have to explicitly say that we are stack allocating these values. And the same with this method, which is this method is similar to write byte array, but it is accepting a span of byte. And again, we have to use stack alloc, and we have to do the casting. Now let's give a look at what collection expression offer. The new style is this. Let's again look at the first two lines. This is basically the same lines we saw before, but with the new syntax. We use square brackets to mean that we are using a collection. We are initializing a collection. So here we are inserting a list of value. In this case, we are initializing an empty collection. Makes sense. What do you think about it? Isn't this much cleaner than the two lines above? And what I really like here is this invocation of the method write byte array for two reasons. First, we don't have to do the casting, and this is because collection expressions come with enhanced inference. Because write byte array is accepting an array of byte, the collection expression or the compiler will be capable of doing the casting for us, so we don't have to do that. And this brings a huge advantage because if, let's say in 6 months from now, I go here and decide to refactor this method, and now it is accepting an array of integers. Now, if I go back to my code, the old syntax is all red. We have a number of errors because we have to clean all this casting or maybe change the casting in order to fix. Imagine if we have, I don't know, 20 calls to that method, we have to refactor all the call sites. Whereas give a look at this line here. It's okay, we don't have to change anything. This is a huge advantage offered by collection expressions. And yes, the other examples, of course, at this point, it's clear that they will be very similar. Look at these spans here. I don't have to do anything except passing the values. I like this a lot. And then there are some optimization that the compiler can do for the compiler can do for us. For example, it is capable of setting the collection capacity as needed, and also it will avoid copying data if it is not necessary. It can do that because these types are well known to the framework. I mean, they are native to the framework, and the compiler and Roslyn know very well how to handle these collections. So we get performance optimization, clean code that is easier to parse and to understand, all for free with the collection expressions. We mentioned that these are the supported collection are basically all the well-known collection, but what about custom collections? Here I have a custom line buffer, which is deriving from an enumerable of char. It has a constructor, it is doing some stuff, it is not important what it is doing, but if I try to use this collection syntax here, I get an error, red squiggle. Why? Well, because the framework doesn't know how to deal with this custom method. What can we do about it? Well, we can actually add support to custom collection to our custom types. There are 2 steps involved. The first one is add a what is called a builder method, so a static method of the same type as our custom type. It will accept a range of values, of course, and in my implementation, it is to simply call the constructor because the constructor is already doing all that is needed, right? We have the builder method in place, but if we go back, we still have errors. Why? Because the compiler doesn't know that this is the actual method to call on collection initialization. So the second step we need to do is decorate our custom type with a new attribute added to C#12, and that's the collection builder. What this guy is doing is, look, compiler, every time you meet a line buffer type, your builder method is create, which is the name that we have here. Probably in here, we want to refactor this to something like this, much nicer. And by the way, the official documentation says that you have to call the method create. That isn't really the case. You can name it however you want. If we rename it to builder, for example, it will work right away. Let's go back to our code. Bam, the error is gone. We can now initialize a line buffer, a custom type, with collection expression synthesis and get all the advantages out of it. This is especially important if you are a library author and want to update your custom types and make them compatible with the collection expression synthesis. Okay, let's go back to the slides and do a quick recap. We saw that collection expressions offer a terse unified syntax. In most cases, they also offer a superior performance. They support a large number of collection types and their variants. Very nice collection expressions avoid refactoring when the underlying type changes. They accept both constant and variable values, of course. They support inclusion of other collection via the spread operator. This one I didn't show you. Let's give a look at it. The spread operator is very nice, something totally new. Here I have two collections of integers, and then I am creating a new one, and I'm kind of merging within this new collection the two previous collections. The spread operator is dot, dot, and then the number of the collection I want to basically unroll inside my collection. If I run this application, I should get an output. Yeah, you see we have basically an union of number 1, number 2, and more numbers, which is a merge of these two and the new values. And again, we get a performance optimization as well. We saw that we can add support to custom expression to our custom types. There is also a symmetricity in syntax with pattern matching and slicing. The dev team did a very good job here. Again, let's go back to the code and give a look at the student record. Not surprisingly, here we have a pattern matching switch. Give a look at the left side of the pattern matching. The syntax here basically is something, the logic here is something like, if there are no grades for this student, then return 4. If there is just one value, one grade, then return that grade. If there are more than one, then return an average. But what it is important here to note is that the syntax is the same of the collection expressions. So yeah, the language is keeping its uniformity, which is very important. We saw that Visual Studio Code and Visual Studio offer good support for primary constructor, and it also offers great support for collection expression. I have an example here. I have to increase the font size as well. So here we have old style constructor. We are initializing a number of things. We don't understand what these things actually are because I'm using the shortened syntax on the right side. But if we look at this last two lines, we have an option to switch to collection expressions. And as we do that, we get a much cleaner code. We immediately understand that these two are actually collection, while these one are concrete types. So instances of some kind of type is not relevant right now, but I wanted to show you how easy it is to switch to collection expression because IntelliSense offers us to do that. Here I have another small example. This is returning an array of custom types. I can go here and again switch to collection expressions. Very nice. Right. And what about dictionaries? In other languages like Python, for example, F#, we also have dictionary expressions, like they work like collection expressions. Well, this was a question that was made to Catherine Dollard, which is one of the a prominent member of the dev team, and she answered that they are working on it, thinking about how they can implement, trying to find the right design and syntax. So it's likely that in some new version of C# we will also have dictionary expressions. They are less important, I should say, less often used than collections, but it would be nice to have them. Okay, let's go and switch to alias any type. This is again a new feature. Now, aliasing a type is something we've been able, we can do since a few releases ago. Let me go back to my code. Our student record is accepting a string, an integer, and an array of grade. What is grade? Well, grade is simply an alias on system.decimal. What C#12 is adding is that now we can also use native type, whereas until today we could we could use type aliases only for named types. Now we can use native types like decimal. The reason we use these aliases is to make our code easier to understand, easier to reason about, more semantic, if you will. Let's go back to the slide. This is probably a more interesting example, a more compelling example. Here I'm declaring a type called point. This is in fact an alias to a tuple of integers. And then I can define a class experiments, which is accepting a point and a grade. Grade, of course, is aliased on a decimal. Now, this is a class named experiments, and the experiments are going to be done on a point and a grade. You can listen to this sentence and understand what this class is probably going to do without much issues, whereas if here we had a tuple of integers and a decimal, it would have been more complex to understand what this class is doing, right? And we can use these aliases even in properties, of course. And because these are just aliases, we could also define a property like this one you see here. This is a tuple property, but we can assign our point to it because essentially they are the same. The same here with the decimal property. I can assign a grade without any problem. And because these are aliases, I can also leverage all the features that the underlying type is offering. For example, distance is a named tuple. And when I instantiate a named tuple, I can unpack it like I can do with all the named tuples. So distance 10, 100 can be unpacked to magnitude and direction and use those values right away. So I hope these aliases will see a wider adoption in the future because coming from F# and functional languages, we use type aliases all the time. All right. And then we have default lambda parameters. Small change, but important one. Until today, we could not have optional arguments in our lambdas. Now we can. Increment here is optional. We'll assume the default value of 1, if not specified, like in this first line here. This would raise a syntax error in previous releases. Now we can have default values or optional parameters in lambdas. Nice to have, I would say. Now we're entering the performance optimization section. Ref read-only is basically the missing step in the passing by reference or by value scenario. I have an example, which is essentially the same we see here in the slide. Let me go to the helpers file. All right, so here we have a method that is accepting a big structure, some kind of big structure, and it is defined as ref read-only, which means that you can only pass this structure by reference, even if it is read-only. Until C#11, you couldn't do this, now you can, and this make it so that if you don't, this is the call site, I'm calling this method, if I don't use the ref keyword, I get a warning. Argument 1 should be passed with ref. There is a big difference because if I don't use ref, I will pass the structure by value, which means that a copy will be made of our structure. And I don't want that because it is going to occupy memory and also it is going to be much slower. So ref read-only is an optimization, the final step that was missing in passing by reference. Passing values by reference or by value, you can specify that it must at all costs be passed by reference. This is mostly used in the .NET framework code base, like the other and the last features, which is inline arrays. Inline arrays are a way, an attribute that you can use on structures. And in this example, what we are saying to the compiler is, look, every time I use a buffer, I instantiate a buffer, I'm actually creating a buffer an array of 10 buffer items. We see the usage here, var buffer equal new buffer. This actually means I'm creating an array of 10 buffer items. And we see in the for cycle that we're using this buffer as an array. Again, this is all about optimization and performance. In this way, the compiler can allocate the space. We could do something similar in the past, but we had to turn on the unsafe features by adding the unsafe keyword into the CS project file of the project. So it was kind of cumbersome and prone to errors. And now it is much easier. And again, you will probably be using this stuff only if you are really keen on performance. And again, this is a feature that they added mostly for using it inside the source code of the framework itself. It's all over the place if you look at it. I think we are almost done. One thing I want to show you is that just yesterday, by pure coincidence, on the official dev blog, .NET dev blog, David Pine posted an interesting article on collection expressions. If you are interested, I suggest you give a look at it. Probably there are most of the things I said in this talk are there. Maybe there is something more you may want to look at it. And this is actually a series of articles, and there is also one on primary constructors. So if you are curious or you want to go deeper, you can go and check the .NET official dev blog and study a little bit more than what I said here in the talk. All right. I think this is all. If you want to get in touch with me, you can go on my website, nicolaiarocci.com, or find me on Twitter, or if you have any question, I'm here to answer. No problem. Thank you.
Thank you, Nicola. As far as I see, there are two questions.
Yeah.
It's better if I can display and you can read it.
All right.
One's coming from the Sean Butler. Can you see the question?
Yeah.
That's great.
For collection expression, if we use an int variable rather than a constant expression, does this fall to compile? You mean a var? The var keyword I forgot to mention. Let me go back to the example code. This is something I wanted to show actually. Distance. Sorry, program. Right. So here, when we use collection expression, we can't use var. And the reason is that at this point, the compiler is not capable of understanding what it should do with the right side of the expression. So this is kind of a compromise you have to take. If you want to use var, you want to use the old style syntax, or when you refactor your code, you also have to do the left side change, update the left side and specify the type. This is only true when you initialize a property in your code like this. For example, when you call a method, this is of course not necessary. The same here, it wouldn't make any sense to declare something like, if I try to, I don't remember what the name is. Yes, if we try to use a var here, it won't work for the same reason. If that was the question, I hope I answered.
That's great. The second question is from Marvin.
Yeah. So this one is, do you have a URL? Yes, I can pass it for you for the blog post I mentioned. I can post it right into the chat. I hope that's enough. Let me see. How do we add link chat? There, you should have it now.
That's great. And a question from Marvin, so I'm going to display it.
Yeah. With type aliases, for example, point, is this alias visible from other class files or does it appear as an analyzed type? That's a good question. I don't think it appears as a type outside of your module, or I should say of your library. But to be honest with you, I didn't try that, so I'm not sure. It would be very nice if it worked. I will do an experiment and let you know, but I don't have a clear answer right now.
Okay, I'm just checking if there's another questions. I believe there was 3 of them. And I'm just waiting a bit more if someone else is going to ask any questions. I'm also checking the chat.
Yep.
And I believe that's all. So I would like to thank you, Nicola. That's a great presentation from your side. So
Yeah, you're welcome. And
so thank you,
again,
Dan. So all the listeners, so meet you in 15 minutes for other presentation.
all right. Thank you,
Bye-bye.
guys. See you soon. Bye bye.